Hello. Um, if you're watching this video, congratulations. You've made it to the second half of Chapter 11 in Advanced Algebra C. But, whatever. Hopefully you're still healthy and at home and hanging out. And it'd be great if this lesson would be delivered in person, but we'll see if that happens. So, either way, we're going to run through, try and keep this short. To start off the second half of our probability unit, we're going to talk about what's called conditional probability. And we'll define that in just a moment. Our EQ is how can I use two-way tables to find conditional probabilities. So we'll get into that in just a second. As a brief warm-up, what is the probability of drawing two cards and getting the following results? A queen followed by a 10. Now, I didn't put the words without replacement there. And normally you would see the words with replacement or without replacement. We're going to assume, since I'm drawing two cards and it says a queen followed by a 10, that the first card is not going back in the deck. So the probability that the first card is a queen, well, there are 4 queens out of 52 cards in the deck. And then a 10 after that, well, there would be 4 10s in the deck still. But assuming we got a queen on the first card and we didn't put it back in the deck, we'd be down to 51. So we have 4 out of 52 times 4 out of 51 times 4 out of 51. As a decimal, that is 0.006 about. Or if we want the fraction version, it is 4 out of 663. So that's the probability that you get a queen, and then it is immediately followed up with a 10. The same idea, but instead of that, so again, this is a different problem. So we are resetting all 52 cards are back in the deck. What's the probability? Instead, we get a red card followed by a black card. Well, if it's red, should probably underline it in red. There are 26 red cards out of the deck of 52. And then if I follow that up with a black card, so assuming I get a red card on the first one, there are still 26 black cards in the deck, but that red card's out of there. So now I'm down to 51. So we have 26 out of 52, which is just half, times 26 out of 51. So the decimal probability is 0.254 or 255, we'll call it, since it's a 9. Or as a fraction, 13 out of 51. Okay. So those are the probabilities of that happening. So that's the multiple events from section 11.3 that we talked about. All right. So conditional probability is essentially saying what is the probability of an event happening given that some other event has already happened. So we've been doing conditional probability without actually stating the words conditional probability. Okay, so the kind of the dictionary definition or the phrase that you're going to hear a lot is given that. So what we're going to find is the probability of some event happening given that another event has already happened. So we know this event happened. Now what's the probability of this second event? Okay, so if we look at that second warm-up problem, okay, our event A, or our first event that was listed, is drawing a red card. Okay, what's the probability I draw a red card? Well, we said that was 26 out of 52, or half. Okay, now, if we started over, we went all 52 cards back in the deck, and we said, all right, what's the probability that the first card you draw is a black card? Just what's the probability you pick a black card out of a full deck of cards? And that would also be 26 out of 52, or 1/2. But what we did in the warm-up was a conditional probability. What is the probability, and here's how it's going to be written, is what's the probability of event B? This bar means given. Okay. Given event A has already occurred. So this is saying what's the probability of drawing a black card given that we have already taken a red card out of the deck. And what we saw is that that does change the probability. Instead of 26 out of 52, it's 26 out of 51, which is slightly higher than 50%. Okay. So the given probability, this is 0.509. This was just 0.50. So the probability of drawing a black card goes up if you've already taken a red card out of the deck. And so that's the idea behind a given probability. So what you're going to see a lot, again, just to reiterate, is things that look like that. What's the probability of event B given vertical line that event A has already happened? So this is, you're going to see data given a lot like this, or in this way. This is called a contingency table or a two-way table. It gives survey results in a compressed, condensed form. So for instance, if we asked, and I think this was an example in the previous video, if we asked, what is that? Is it 5? Yeah, if we asked 500 people, do you play a sport and do you play an instrument? We could lay out the data like this. So 50 people said yes, they play both a sport and an instrument. 200 people said they don't play a sport and they don't play an instrument, and then you can interpret the other cells in there. Okay, so this is what's called a two-way table or a contingency table. So what we could say then is determine the probability that a student chosen at random plays a sport. Okay, if I pick one of these 500 people, what is the probability that they play a sport? Now, what can be misleading is, first of all, what's my sample space? And the sample space is everyone, right? I'm picking from everybody. So that's out of 500. The question is, what is the probability that someone plays a sport? And it's not 50. My numerator is not going to be 50 because I have, if I look at plays a sport and you said yes to that, both of these sets of people said yes to playing a sport. 50 of them play both a sport and an instrument, and then 100 play a sport but not an instrument. So if we ask the question, what is the probability that a student chosen at random plays a sport? This would be 150 out of 500. Okay, I'm going to resize this. So 150 out of 500, which is, I can divide those both by 50 and get 3 out of 10, which is 30% or 0.30. Okay, so that's the probability that someone plays a sport. Notice 150 and 500, neither one of those numbers show up in the table. Okay, we have to use some interpretation skills to understand what this is saying. So if we go back to here, determine the probability that a student chosen at random does not play an instrument. What is the probability that a student chosen at random does not play an instrument? Again, since it just says a student at random, we know we're working out of 500 total. Then how many people don't play an instrument? Well, we have to look at plays an instrument and no, and there's a total of 300 people there between the people who said no to an instrument that both play a sport and that don't play a sport. So this is going to be 300 out of 500, which reduces to 3 out of 5, which is 60%. Okay, so you have a 60% chance of picking someone who doesn't play an instrument based on the data given in the table. And finally, we have, what is the probability that a student chosen at random plays a sport given they play an instrument? Now, here's where the new conditional probability piece comes in, okay? And this phrase, for the rest of this lesson and the rest of really the unit, if you see the word given, the phrase that comes right after that is so important, okay? What I know about this person is that I'm not picking from all 500 people. I know they play an instrument. And the question is, if you know the person you're picking plays an instrument, what's the probability they play a sport? So if I look at plays an instrument and the people who answered yes to that, there's a total of 200 people who play an instrument. Okay. Well, of those 200 people, only those 200 people, okay? So I'm not even worried about this right now. How many of those people play a sport? Well, how many people, just to reiterate, how many people play a sport? It's only those 50 people. So the probability here would be 50, but not out of 500. It's only out of 200. Okay. The fact that the given event is that they play an instrument, that narrows down my sample space from all 500 people to just 200 people, because that's the number of people that I know play an instrument. So 50 out of 200 reduces to 1/4, which is 25%. Okay. So really, in a nutshell, what's going to happen is if you see the word given, your sample space is changing. Okay. It is going to change the denominator of your problem and the numerator, but really the denominator is the important piece. Okay. So let's look at another example real quick. Gender breakdown of college students in 2005 is as follows. Okay. So there's males and females. Again, these numbers are in thousands, so there should be 3 zeros attached to each one. And then it's split up by 2-year colleges, 4-year colleges, or grad school, which means master's, doctorate programs. Okay, so this says for one person chosen at random, find the probability that the person you pick is female. Now, there's no given information here. Okay, there's no given event. So I want to know what's the probability that I pick a female, which is all of those 3 cells in the table, and my sample space is everybody. So I do have to do a little bit of addition. If you want to skip through this part just while I type in the calculator, what I will say is that if you go through this work, go ahead and put the total underneath, because that's going to help us later on. And then I also want to know, so I'm adding the total number of males right now, 1349, 7539. And then if I add both of those numbers up, I get the grand total. So my giant sample space is 17472. Okay, so my sample space is going to be that number I just found, 17472. And then my event space is what's probably I choose a female, which is 9933. Okay. And again, for these big numbers, we're probably not even going to care about the reduced fraction version. I'm going to go ahead and just put as a decimal. So 0.569. So about 56.9% chance that you choose a female if you pick at random. Okay. Now the next question is saying, what's the probability that you choose a female given they are in grad school? Okay. So again, that vertical line means I'm not picking from everyone. I am picking only from the people that fit this condition, that they are in grad school. Okay. Which means I'm not even going to use the 17472 anymore. I am only looking at this set of individuals. Okay. Because those are the people that are in grad school. So total is 3303. So that's going to be my sample space. And then the event space is what's the probability that of those, of all the grad school students, what's the probability that you choose a female? Well, that's going to be that number right there, 1954. And just to reiterate, I am not using this number right here because that includes everyone, all the females, not just the grad school. So I have 1954 out of 3303, which is 0.591, 0.592. So you see that the probability goes up slightly the probability of picking a female goes up slightly if you narrow it down to just grad school. So 59.2% chance that you pick that you choose a female if you are looking just at grad school. Okay, and then one more example of this is what's the probability that you choose someone who's going to a 2-year college given that they are a male? Okay, So again, I'm going to narrow down my scope. I am not looking at all students. This is saying of the male students, if you just put, if you're choosing just a male student, what is the probability that they go to a 2-year school? So now my sample space is going to be just the male students. So that's at 7,539. What is the probability that they go to a 2-year school? Well, that's this right here, 1866. So then that's my probability fraction, and I can type this in and get my decimal answer. So it's really all about breaking down, kind of just narrowing in on the set of people that you are interested in based on the information that's given. Again, that vertical line is saying you are reducing your sample space to only this type of person, or only the people that have this characteristic. So go ahead, pause, give this one a try real quick, and then we'll wrap this up. All right, 50 people are asked whether they pay their bills online. So that means that right there tells me that the grand total of this should be 50. And sure enough, if I add these up, there's 36 people who pay online, 14 that pay by mail, which adds up to 50. And then going across, 20 males answered this survey and 30 females, which also adds to 50, which is great. So what is the probability that they pay online given that they are male? So again, I am only working with the males in this problem. So out of 20, the probability or the number of those 20 that pay online is 12. And 12 out of 20 is 0.60 or 60%. Again, I could do a reduced fraction, but I'm just going to stick with the decimals for now. And then this next portion, what is the probability that I choose a female given that they pay by mail? So if I know they pay by mail, I am only looking right here at these 14 individuals. So out of 14, how many of them are female? And that is 6. 6 out of 14 is 3 out of 7, which is 0.42. 0.429. 0.429. Okay, so that's how we use a two-way table to convey conditional probabilities, which is what we just said. Again, really, what I want to get at here is that this means given event A, and this is reducing your sample space. And we'll leave it there for now. And the next video will kind of wrap up 11.4. Stop sharing.